This is our video for EA3, identifying a relationship between variables. When we do an experiment, we sometimes see that one variable affects another. This is called a relationship between two variables. If a pattern exists, you can state a relationship as if independent variable increases, that is like name the independent variable here, then the dependent variable, whatever that is, will either increase or decrease. If you see the dependent variable not change at all, then there's no relationship. So we may see situations where the dependent variable does not depend on the independent variable, in which case there would be no relationship between them. But if we see a relationship, then that means that the dependent variable either increases or decreases. So I want to show you an example of some really nice work from today. Period 3 had an amazing day today. Almost every group in the room totally killed it. People who didn't do their homework got it done quickly and still got a lot of other work done. And most people in the class did their homework. So really, really nice job, period 3. Let's look at some of their work. This is Khadijah's data table. She was working with Anaya and Maju and Hamed. They all did fantastic work today. And we can see from looking at these numbers that there is a pattern in these numbers, that as the drop height numbers decrease from 100 to 80 to 50, the bounce height numbers in general decrease also. If we look at all the 100 centimeter drop height numbers, 70, 60, 64, 67, 83, they're not all the same, but they're all pretty big numbers. Whereas if we look at all the 30 centimeter drop height numbers, 20 centimeters, 18, 23, 23, 18 for the bounce height, they're all much smaller than the numbers up here. That is, we notice two things. The same drop height doesn't give us the same bounce height every time, but in general, the pattern shows that as you drop the ball from lower, the bounce height is lower as well. Of course, this makes sense. You probably knew this already. If you drop a ball from higher, it's going to bounce higher. If you drop the ball from lower, it's going to bounce lower. But we're seeing this pattern in the numbers. It's not obvious because there's some complexity in these numbers. That is, like if you drop the ball from 80 centimeters, it doesn't bounce to the same height every time. But we can still see the pattern. The question is now, how is the best way to show this pattern? And I want to show you an example of a really nice set of graphs. These two graphs are from Sam and Jesusen, who are working together with Yakuba. And I'm choosing to show Jesusen and Yakuba and Sam's work because there's an interesting difference between them. I'm going to back this up so we can see both of these graphs together. They're showing the same data, and they're showing it in a beautiful way, but notice there's a slight difference between them. If you look closely at Jesusen points, you can tell that the points are spread out up and down, whereas if you look at Sam's points, they're spread out side to side. We see the same spreading out, but they spread out in a different way. I just want to point out that's because Sam graphed bounce height on the x-axis, and Jesusen graphed drop height on the x-axis. We're going to end up doing things more like this, where the independent variable goes on the x-axis, but there's no real reason for it other than that's the way people do things in general. But I want to point out that looking at this pattern is kind of really straightforward when we put it on a graph. Even though we see that these points are spread out from each other, just like we saw those numbers for the bounce height are not always the same, we can still see that there's a pattern here. In general, as the drop height goes up, the bounce height goes up also. And that pattern's really obvious when we look at this graph. This is a beautiful graph. Sam's graph is also beautiful, and it shows the same pattern. As the drop height increases, the bounce height increases also. Our big question tomorrow will be, how can we go one step further to show this pattern in even more detail? Here is one suggestion of how to do that. This is work from Esther, Isaiah, and Kiara, who are working together. They were a little rushed because they were making this graph at the end of the period because a couple of them didn't do their homework, but they still did amazing work. This is still quality work for the day. And they did something interesting here is they're trying to show more about the pattern by connecting the dots in this way. My question would be, does connecting the dots in this way tell us more about the pattern than just graphing the dots without connecting them does? I think I would argue that connecting the dots in this way doesn't actually show us more information, that it actually looks really confusing to have these lines like kind of crisscrossing across the page. This kind of looks like the pattern is clearer if we leave the line off. One last thing I want to show you is from first period. This is from Wendeley and Triana and Isaiah King, who are working together. This is a different way of thinking about the graph, where you can see they put 10, 10, 10, 30, 30, 30, 50, 50, 50. We don't see the points spread out above like this. And notice from here to here, from 100 to 200, there's a little jump on the x-axis, but a giant jump on the y-axis. That is, I would argue again that having a scale that looks like this, where we put the number 10 3 times, instead of putting the number 10 at just one place and saying like, okay, that number 10 is right there. Having this scale is actually going to make it more difficult for us to see the pattern. Again, this is still a beautiful graph. A lot of graphs made this way can be very, very useful. But if our goal is to find the pattern, I think that graphing like this is going to be the most useful way to do that. But we're going to talk about how we can say more about that tomorrow when we talk about graphs in class. So last thing we want to write in these notes, we want an example of how to identify this pattern. For this lab that we just did, I just want to put the independent variable and dependent variable in as an example here. So if the drop height increases, that is, the independent variable was the drop height, so I'm saying if the drop height increases, then bounce height increases. We see that as the drop height increases, the bounce height increases also. That's what this graph is showing us. As the drop height increases, the bounce height increases also. We've also seen situations in our noodles lab, if the separation of books increases. I'm talking about the pasta bridges, the noodle bridges lab. If the separation of books increases, the strength of a noodle bridge, maybe you see where I'm going with this, the strength of the noodle bridge, that is like the force required to break the noodle bridge, decreases. So you can see how both of these are relationships that we could identify, but in one of them we see as the independent variable increases, the dependent variable increases, and in this other one we're saying that we can also show that the dependent variable could decrease when the independent variable increases.